Good evening, ma'am. My name is Tina Veshra. I am third year from CSCB section, bearing my roll number 234G1A05B1. My CA2 topic is automated abstract syntax tree. Before we entering into the topic, first of all, we discuss the headlines of this topic, abstract syntax tree. First, introduction, structure of an abstract syntax tree, and tree representation, example, and finally conclusion. Introduction to abstract syntax tree, commonly we call it as AST. An abstract syntax tree is a hierarchical tree-like representation of structure of an source code. It abstracts away unnecessary details like punctuation and formatting, focusing on the syntactic structure. Abstract syntax tree or essential in compiler design, code analysis, and transformation process. It enables syntax checking, semantic analysis, and code optimization efficiently. Intermediate representation of the source code as a tree structure. First of all, abstract syntax tree is like a hierarchical tree representation. It used to represent the structure of the source code, and this abstract syntax tree is removes the unnecessary data like punctuation, formatting, and focusing on the syntactic structure. This AST abstract syntax tree is essentially used in compiler design and mainly in code analysis. Um, Enables syntax checking, systematic analysis. This abstract syntax tree is used to intermediate representation of the source code as a tree structure, used to represent the source code as a tree-like structure. Structure of an abstract syntax tree. An abstract syntax tree consisting of nodes representing language constructs such as expressions, statements, and operators. This AST consists of expression systems, statements, and operators. Each node can have the child nodes illustrate the hierarchical relationship between the code components. This AST contains the nodes like child, parent, and sibling nodes. It used to represents the relationship between the code components. Leaf nodes is nothing but the child nodes and typically represent the basic elements like variables, literals, or identifiers. These leaf nodes are used to represent the literals, identifiers, and variables also. This abstract syntax tree are generated through parsing, which convert the raw source code into structured tree-based format. This AST is generated. It's used to convert the raw source code into structured tree-based format. Simply convert the source code into this tree-based structure. This is the tree representation of the abstract syntax tree. First, this is the top of the node is called the root node, and expect the top node. Remaining nodes we call that parents, siblings, and child nodes. First, we represent the parent, child, and also sibling nodes. This is the tree-like representation of the abstract syntax tree. Finally, this compiler, how they use it to execute this abstract syntax tree means, as shown in the image, this is the working of the compiler. The front end takes the input source code. This is the front end. Front end takes the input and generate the abstract syntax tree, which is then proceeded by the backend to produce the output. First of all, this front end is used to take the input and is generated the abstract syntax tree on the back end, and it generate the output. In short, we like to tell like it represents the flow from it takes the input from the front end, generate the abstract syntax tree from the back end, and gives the output. This is we've written the source code in C++. This C++ code is compiled the mission. First, it's used to compile in mission level language uh, in form of mission understandable language, nothing but the binary language. A program written in C++ source code. This is used to give an input to the compiler. which process generates the machine code in form of binary. Okay, this shows the transformation of the human reliable code into computer execution instructions. After execution of the binary, it generates this output into human readable code based on the executable instructions, computer executable instructions. This is the example for the abstract syntax tree. The root node is the addition operator. We can see the top of the root node, we have the plus, nothing but the addition operator, which contains two nodes. Those are multiplication subtree 4 into 10. This demonstrates how expressions can break down into a tree structure the following operator precedence. First of all, in the top node, we have the plus and addition operator. We split two nodes like 2 and multiplication also. Uh, we 2 plus into 4 into 10. This is like expression. The expression we converted into abstract syntax tree. Using this abstract syntax tree, we use it to calculate the solution or output. This is the example for abstract syntax tree. And each part of the expression is break down into nodes. We have written, this is the code. Type binary expression indicates an operation operator plus or multiplication defines the operation values 2 4 10. We've written the values 2 4 10. First we use it to calculate these values. First, according to the precedence, we takes calculate first multiplication operator. So we use it to calculate the first 4 into 10. Then this structured representation makes it easier for compiler or interpreter to analyze and evaluate expressions systematically. It demonstrates how code is internally transformed into a tree-like data structure for processing. After we solve 4 into 3, we use it to add, then we use it to add, we can get the output. Common application of abstract syntax tree. Counting how many times a function, variable or component is used in source code. Transforming code from one syntax to another. Enforcing rules for syntax. This is the common applications in abstract syntax tree. Thank you, ma'am. Thank you so much for giving this opportunity.